Students, this is Unit 8, your last 8 of the year. We're going to be talking about area and solids. Lesson 8.1, Quad Family Tree Area. Make sure you get the date, time, location, and a parent sign-off. Let's do a review. Below is a circle inscribed in a square. The side length of the square is 12 centimeters. You want to find the area of the shaded region, round everything to the hundredths place. Do this on your own and then restart the video. Pause. Welcome back. Let's see. To get this shaded region, let's make a thing equation. You always want to do a thing equation before you do numbers. So we're basically going to take the area of a square. We're going to find the area of that square. And then we can find the area of that circle. And then to get the original shaded region, you basically subtract. The square is side squared minus pi r squared. So we were told that this is 12. So side squared is 144 minus pi. If that's 12, this is also 12, which means our radius is 6 times 6 squared. So we're going to go 6 squared times the pi key. You get 113.1. Subtract those two. And you get approximately 30.90, and you should check for units, centimeters squared. Shaded region, 30.90 centimeters squared. Remember, you do things before the numbers. That was square minus circle gave you the shaded region. We're going to be finding the area of the various quadrilaterals in the quad family tree. We're starting with the area of a rectangle. You guys know area of a rectangle as basically length times width. And if you use length times width, that is perfectly fine. But keep in mind that because there's a right angle, there's another set of terms we can use. Anytime there's a right angle, you have something called height and base. So we could also call this base times height, because base and height always meet at a right angle. So area of a rectangle, length times width, also base times height, exactly the same thing. So when we're working with area, when we see the word height always creates a right triangle, or right angle, excuse me, a right angle, which hints at some point there'll be right triangles as well. So whenever you see height, know that there's going to be a right angle there somewhere. Now, a parallelogram, if you notice, a parallelogram is essentially just a rectangle pushed on its side. Because if you take a moment and shade this leftover triangle, just shade it. Now bring it over here So you see that this rectangle, if you will, this rectangle would be base times height. So this parallelogram is exactly the same thing, base times height. What you need to understand here is that the height is at a right angle. This black squiggle, that is not the height. It doesn't create a right angle. So whenever you have a parallelogram, you're going to do base, and the height is in one of two places, either straight down on the inside, or you can even measure it from the outside. But it's base times height. Basically, it's the same thing as the rectangle. Let's do a couple problems here. Finger track and read out loud. Read with me. Put your finger right on that paper. The base length of a rectangle is twice its height. The perimeter of the rectangle is 30 feet. What is the area? Should be underlining. Okay, let's interpret step by step. The base is twice the height. So if our height is x, our base is 2x. The perimeter is an equal sign, 30 feet. We want the area. Now let's write down our area equation. Area equation, base times height for a rectangle. Problem is we don't have any measurements here. Let's look at what we do have. Physically walk that perimeter around. Just walk it around. Trace. We know the perimeter equals length plus width plus length plus width. Let's circle plug chug. Perimeter we can place with 30 equals our length 2x plus x plus 2x plus x. Let me color code that for you. Let's solve. 2x plus x, 3x, 2xx. Area equals base. Base is now 10. Our height is 5. Check your units. It's going to be feet squared. Couple things. One, I underline my key words. 2, always write your equations out. Notice I wrote the equations out. 3, circle, plug, chug. Physically pick up stuff as you plug it in. Read this out loud. Finger on the paper. The area of a parallelogram is 72 centimeters squared. Base length is 12 centimeters. What is the height? Underline your key words. Let's draw. We have a parallelogram. We know its area is, that's an equal sign. Right underneath, write the equation. Our base is 12. Our height, we don't know. Circle plug check. Ready? Let's circle. A for area. Look what we can replace. 72. Base. 12. height, don't know. You can see as you circle, plug, chug, now you can solve for x. So I just found my height is 6, check units, centimeters. All right, now we're going to do area of triangles because you're going to need that for the next section. Remember, area of a parallelogram is basically base times height. Let's write that down. Go ahead and divide that parallelogram in half. Shade half. When you divide a parallelogram in half, ask yourself, what shape do you get? You get a triangle. So a triangle is half a parallelogram. So if a parallelogram is base times height, triangle is simply base times height over 2. Area of a triangle, base times height over 2. Sometimes in other textbooks it's written like this. I personally don't use that one because students get confused. Is it half of the base? Is it half of the height? They get all mixed up. Don't worry about that. It's just base times the height, divide by 2. Now, height is the key here. They give you a little animation because something kind of weird happens with the height of triangles. Take a look here. This is called the Math Open Reference. So in this, okay, so look in the corner there. Our base is 14. Our height is 4. We divide by 2. Now, take a look. That height is inside the triangle. This is an acute triangle. Now, watch that red line. That's still an acute triangle. Looky there. Notice my height, if it's a right triangle, my height is actually on the side. Watch what happens when I drag to an obtuse. The height is now outside. So once again, in an acute triangle, the height is inside. In a right triangle, the height is on a side. And in an obtuse triangle, the height is outside. So that's very key there when you're working with base times height. In an acute triangle, the height is inside. So label your base and your height. In an obtuse triangle, the height is outside. And in a right triangle, the height is on. So let's write the area equations for all of these. For the acute triangle, area equals that base times that height over 2. For the obtuse triangle, trace with me, please. It would be that base times the outside height over 2. For a right triangle, it would be the base times the height over 2. Now there's one caveat in the right triangle especially. The base and the height are also the legs of the right triangle. Notice that. They also are the legs. So another way to find the area specifically of a right triangle, and this only works a right triangle, one leg times the other leg over 2. That only works for right triangles. So now, because you know the triangle equation, let's write that in the corner. Triangle equals base times height over 2. Now we're going to go for a trapezoid. Trapezoid, if you go like this, it's basically 2 triangles. Do you catch that? You go from edge to edge. It makes 2 triangles. Area of a triangle is base times height. So in this diagram, the height would be here for that bottom triangle, and the height for the upper triangle is right here. Notice the height is still the same for that triangle. Problem is the bases are different. So the area of that triangle, it's essentially 2 triangles. Watch very carefully. We'll call this down here, we'll call this base 1, base 2. It's base 1 times the height over 2 plus base 2 times the height over 2. The only thing is we have 2 different bases. We have 2 different triangles. There's one, there's the other. Now we're going to clean up this equation because that's a little too messy. So let me show you the shortcut. We're going to take out everything that's the same. There's a height in both. So we're going to take out that height. You ask yourself what's left. If you look at what's left, basically we're simply averaging the bases. Base 1, base 2, over 2. That is the area of a trapezoid. As you average the bases, add, divide by 2, then times the height. So area of a trapezoid is the average of the bases times the height. Average of the bases times the height. Last one, rhombus and a kite. Rhombus and a kite. The reason why these are together is they have the same equation. Rhombus and a kite. And what makes them the same? I'd like you to trace the diagonals. If you have 2 different colors, do so. Both of these diagonals, they make right angles. So that's why they share the same equation. is because they have that same property to find the area of a rhombus. Now, a rhombus also qualifies as a parallelogram. So technically, you could do base times height over 2. But both of these, you simply take the length of one diagonal times the length of the other diagonal, and you divide by 2. Trace with me again. It's going to be one diagonal times, trace with me the other diagonal, over 2. So it's the first diagonal times the second diagonal over 2. Here's your quad family tree. Let's trace everything and write out our equations. Remember, equations have two sides with an equal sign. So every single one of these, you start with area equals. Parallelogram, base times height. Rectangle, base times height. Also, length times width, same thing. Square, technically you could do base times height, but you just take one side and you square it. Since a square qualifies as a rhombus, so a rhombus is going to be one diagonal times the other diagonal over 2. A square also qualifies as a rhombus, so you can also do one diagonal times the other diagonal over 2. The square could use both because it also has a right angle in the middle. Kite, one diagonal times the other diagonal over 2. Trapezoid. You average the bases, base 1 plus base 2 over 2. That's average the bases times the height. These must be memorized. We're going to do 2 problems together, and then you're going to do 2 problems together. Step 1, put your finger on the paper, read this out loud. A kite has an area of 90 centimeters squared. The longer diagonal is 15 centimeters. Find the length of the shorter diagonal. 2, we're going to underline our key words here. 3, we write our equations. We're going to draw and label our drawing. We have a kite. Area of the kite is 90 centimeters squared. I like to cross stuff out. Longer diagonal, 15 centimeters. Shorter diagonal, unknown. Now we circle, plug, chug. Area equals first diagonal times the second diagonal over 2. Always write your equations two sides with an equal sign. Since the A's are equal, I can swap out A. I can put that in there. Our one diagonal we already have is 15. Our other diagonal we don't know. And we're going to cross multiply. Get your hands off those calculators. My shorter diagonal is 12, check for units, cm. Equations have two sides with an equal sign. Then you very carefully circle, plug, chug. Follow along. Read this out loud. The area of a trapezoid is 160 meters squared. Bases are 12 meters and 20 meters, respectively. Find the height of the trapezoid. Step number one, we're going to draw. We have a trapezoid. Bases, shorter base, 12 meters, 20 meters. Notice I'm crossing stuff out after I label. Height is our unknown. Last thing we are given. Draw a label list, cross out. Ask yourself what you can do. You can always write your equations down. Two sides with an equal sign. Area equals average the bases times the height. Let's see what we have here. Circle, flag, chug. Area. We have the area. Physically plug it in. Base. Our other base. We're going to average them times the height. Remember, you follow PEMDAS. You're going to do what's inside the parentheses first. That's basically 32 divided by 2. Thirty-two divided by 2 is 16. Sixteen goes into 16 one time, and you have a 0 there. You just found your height is 10. And check for units, meters. Always check your work. Always check your work. Plug that 10 in, see if it actually works. Okay, this page, it's super important you get a little bit of practice working on your own. Take the time. Pause the video. It should only take you about 5 minutes. Have a red pen handy when you're done. Restart the video. I expect to see corrections. If you're correct, smiley star, red pen. If you're not correct, I expect to see corrections here. Pause the video. Don't copy by cheating. Pause. Okay, welcome back. We have a rhombus right here. A rhombus has a side length of 5 feet. The longer diagonal of the rhombus is 8 feet. We need to find the area of the rhombus. Let's write our equation out. Area equals diagonal times the other diagonal over 2. Our one diagonal is 8. Wait, you're missing the other diagonal. The other diagonal is not 5. So we're missing that. Let's see what we can do. We're missing it. Let's take a look, see what we have here. Oh, looky there, folks. We got ourselves a right triangle. So we want that edge right there. We'll call it X. Look what we're going to do. Have 2 sides, meet third side, tag. Or those of you who are really smart and memorized your triplets, you'll see right now what that is in just a moment. So that edge right there was 3. Now 3 is not what your answer goes. That's 3, that's 3, that is 6. Area equals 48 over 2, 24. We check for units. And it's feet. So this was feet squared. Okay, guys, several of you did not work with that right triangle. At this point, you should be getting your red pen out, and you should be writing yourself 3 little notes. What are you going to remember in the future to watch out for? Remember how I warned you, your right triangle stuff is going to come back again and again and again and again. Okay, we just need to find the area of the shape below. So there's 2 ways you could have seen this. One way is to have seen it as 2 separate rectangles. And then what you do with those 2 separate rectangles, and I'm going to show you both ways, is you would add them up. So you could find the area of the 2 separate rectangles and add it up. So let's see that way. So this first one's going to be length times width. That's 5 times 3. You come over here. That edge is 2. Physically trace. That edge you don't have. But you do have this edge. That's 6. This edge is 3. Trace it. 6, 3. That means that was 3. So 3 times 2, you end up with 15 plus 6, 21 feet squared. Several of you did not get that 3 there. Again, how did I get the 3? I traced it. And I went, oh, I don't have it. But it's the same as this. And then I keep going. The whole thing's 6. Down here, that's 3. So what's left is 3. That's one way to see it as 2 rectangles. And then you add those up. Now, another way you could have done is seen it as one giant rectangle. See the yellow? And then you could, this is called negative space, subtract or bite out that negative space, and what's left is what you want. And this is going to be 5 times 6. Of course, that giant yellow is 30. And then this edge would have been 3 times 3 square, 9. Subtract. You got 21 feet squared. Notice it's the exact same thing. Check your work, folks. Write notes. If you got it incorrect, put dollar smiley if you did get it correct.